Please get out your note sheet for inverse variations.
Alright, so I want to review direct variation really quick just so you guys can see the main difference between that and inverse variation. So we know in direct variation the x values and y values would increase or decrease at a constant rate, which means if the x's increase, so should the y's, or if they x decreases, so should the y's. And that's what makes the graph a straight line, because they're both doing the same thing. We know our equation for direct variation is very similar to slope-intercept form. So you've got y equals kx, and k is your constant of variation, and you find k by dividing y by x. Another thing that direct variation has is that all of the graphs would go through your origin. So we're going to look at inverse variation, and the word inverse itself is, if you think of, reciprocal inverse or the inverse property, it's basically going to be the complete opposite of what you see for direct variation. So inverse variation is similar to direct variation, but as one value goes up, the other value is going to go down, or vice versa. So they're going to do opposite directions. One increases while the other decreases, or one decreases while the other increases. And because of that, there is not a constant rate, so the graph will not be a straight line, because we want to show x increasing while the y decreases, and that's going to happen at different rates, so then you're going to end up not having a perfect straight line here. So your inverse variation equation is actually the opposite operation of direct variation. Direct variation was y equals k times x, and inverse variation is y equals k divided by x. And then x cannot be 0, and we just know that because you cannot divide by 0, so you'll never actually have a point of the graph here where x is 0 is all that means. And then the constant of variation k can be found by multiplying x times y, and the way you get that is just by solving this as a literal for k. You would get rid of divided by x, so then you would have multiply x on both sides, and k is just the x times the y. In direct variation, k was y over x, kind of like slope is y over x, but inverse, remember, is kind of opposite, so instead of dividing, we're going to just multiply. So here's a look at just a direct variation table versus an inverse variation table. And again, if you focus on those equations, direct is saying that you have some constant that's times x to give you every y. So if we look at -3 times something to get 6, 4 times something to get -8, 6 times something to get -2, you're always multiplying by -2. So k in this case would be -2 if we had to find it. And we can also do y over x to get that. With inverse, if you go from -3 to 2, and 3 to -2, and 6 to -1, there is no constant multiplication going on to get from x to y, and so the equation for inverse variation is that k is, you're basically saying the constant of variation is some number you're dividing each x by to get that y, and then the way you would find k, we said, is multiplying x and y. So if you take each group here and just multiply, we should get the same value. And -3 times 2, 3 times -2, 6 times -1 are all -6. So k is -6, and that would be your inverse variation equation. So determining if inverse variation exists is similar to direct variation, but you're going to check that the constant of variation, which is your variable k, is the same for the entire set of ordered pairs. But the way we check it is, instead of doing y divided by x, we have to use our formula for k for inverse variation, which is just multiplying x and y. So your steps for writing an inverse variation equation would just be, again, very similar to direct variation. It's find the constant of variation, so find k first, and then write your inverse variation formula and substitute your k value in. So once you know k, just plug it in for k, leave x and y as x and y, and then if you need to, you can always use that to make predictions for other inverse variation problems. So for these first 3 examples, we're just going to determine if there is inverse variation, and then if there is, we're going to write the equation. So remember, the equation for inverse variation is y equals, they should always be y equals, just like slope-intercept form, direct variation. So y equals the constant divided by x, but what we're going to do first is figure out if k is constant. So in this first table, we're going to multiply each of these, x times y, and see if we get the same value. So 8 times -6, -48, 12 times -4, -48, 24 times -2, -48. So k equals x times y, it did stay constant in each of these. So yes, there is inverse variation, and our k would be negative 48. So we write our equation as negative 48 over x. The second group, again, we're going to just multiply each group here. So 8 times 4, 32, 10 times 3.2, 32, 7 times 5, 35. So this one does not have inverse variation because you've got those different values, so we cannot write an equation, we're just done. And then your last one, we have 1.5 times 14, and that's going to give us 21. 3 times 7 is going to give us 21, and then 5.25 times 4 is 21. So because all of the products here, or x times y, are all the same value, then yes, k is constant, and we're going to write our equation as y equals 21 over x. Now, if you ever want to check, then you can just say, hey, my y values in all my tables should be the 21, your constant of variation, divided by each x. So if I checked in this example 3 and I did 21 divided by 1.5, I'm going to get 14. If I do 21 divided by 3, I'll get 7, and if I do 21 divided by 5.25, I'm going to get 4. So it's just kind of proving that you get each y value by, in this case, dividing 21 by x. Alright, so your steps for using inverse variations to find unknowns is, again, very similar to direct. It's just that you have to use the inverse variation equation. So it's find your constant of variation, find k, substitute it into your formula, and then solve for the missing value using that formula. So we're going to take a look at a couple examples doing it this way. So example 4 says given that y varies inversely, so here's another difference with direct. Direct would say it varies directly, inverse would say it varies inversely. With x, and we know that y is 8 when x is 3, we're going to find y when x is 4. So we're going to solve for k first. K is your x times your y, and in my first set I know that x is 3 and y is 8, so I'm multiplying and I'm going to say k is 24. So I write my equation, y equals 24 over x, and then I'm going to use that equation to predict. So now I'm going to plug in that 4 for x, and I'll do y equals 24 divided by 4. And I'm going to get y equals 6 as my final answer here. So with inverse, you're trying to create two x and y values that can be multiplied to give you the same k, is ultimately what you're looking at. Example 5, so we know y varies inversely with x. Y is negative 3 when x is 4. So I'm going to go ahead and just start writing that out. And then we're going to find x this time when y is 0.5. So first find k. K is 4 times negative 3, which is negative 12. Write your equation for inverse variation. It should be negative 12 divided by x. Use that equation to predict by plugging in for y this time 0.5. So we've got 0.5 equals negative 12 over x. And basically we're saying 0.5 times what is going to give me negative 12. If you had to solve this at this point as an equation, you would need to treat it like a proportion and cross multiply, and you'll get 0.5x equals 1 times negative 12, and then you're going to divide by 0.5, and we'll get x is negative 24. Now, we want to make sure that's right, then we should be proving that negative 24 times 0.5 is going to give us negative 12, because 4 times negative 3 gave us negative 12, and we should always get that same product when we multiply our x's and y's. Okay, so lastly we're going to look at word problems, and it's again very, very similar to direct variation. So first of all, identify your independent and dependent variables. Then pick some numbers that satisfy the problem and test for inverse variation. And this could depend on the kind of problem it would be, and you'll see that in a second. Step 3, if there would be inverse variation, write your equation after you would find k. And then step 4, use your equation to find any unknowns. So something that is, again, very helpful for inverse variation, like direct variation word problems, would be to make a table if there's not already one there for you. So just a suggestion to try and help you out, especially because sometimes you have a word problem and you don't know if it's direct or inverse, so the table helps you see that as well. Okay, so we have the word problem that says the cost of a $120 boat rental is split among several friends. As we start seeing more word problems, that word split's actually going to be your clue that it's inverse variation. And so what's going to help in this kind of problem, because this might show up and it would say, is this direct or inverse variation, and write the equation. And some people get lost because they're saying, well, there's only one number. So kind of imagine and make up numbers to see what's going to work for this. And, just think about what you're actually comparing here to start. So we're actually looking at how much it's going to cost per person, because we're taking that total 120 that's never going to change and just splitting it between specific number of friends. So your independent and dependent variable based on this problem would represent the number of friends, because it's the number of friends that's going to affect how much each person pays. So I know, again, it doesn't tell you how many friends it is and how much each person pays, but we know the total is always 120. So we can kind of just imagine, well, what if there was one person? That one person pays for the whole boat, that's $120. What if we have two people? Then that's 120 divided by 2, that's 60 per person. If we had 3, then it's going to be 40 per person. If we have 4 people, it's 30 per person. So every time you're adding a new person, the cost is getting cheaper. So you can already see that the x's are increasing while the y's decrease. So this would definitely, again, be your inverse variation. And then k is whatever that total price is that never changes, which we already know is 120. So, and if you look at your table, it's always x times y, and every x times y in this table is going to be 120. So our actual equation here should be y equals 120 divided by x. And that's why this problem only gives you one number, because you really only need one number. That's just that total amount that never changes. It's just going to depend on how many people there are and what the price per person would be to equal 120. Last thing I want to look at is the graph of an inverse variation. So go ahead and pause the video and graph the points in your table on your graph, and then we'll take a look at how you connect those in order for it to be what an inverse variation graph would look like. Alright, so if you graph those 6 points, when you go to connect them, you're going to actually connect it as a curved line. And then something to keep in mind is, because inverse variation is k divided by x, and we said you cannot divide by 0, you're never going to go through the x-axis. So when you connect, you do not want to show that that line ever touches the x-axis or goes through it. And this is a specific kind of graph where your values will get close to the x-intercept and close to the y-intercept, but never actually touch it. So it's kind of a weird, different graph. You'll study more of these in Algebra 2, but basically you're going to draw 2 curves. They're going to be in opposite quadrants of each other, and they're going to just be curved lines that look just like this. So that is pretty much the main difference between these graphs and direct variation. So something to keep in mind with inverse variation graphs is this will always be consistent, that when k is positive, your graphs will end up being in quadrant 1 and quadrant 4, and that's because if you have a positive k divided by a positive x, which would be quadrant 1, you're going to have a positive y. If you were in quadrant 3 and you had a positive k, but you divided that by a negative x, because in quadrant 3 it's a negative x and a negative y, positive divided by negative gives you a negative. And then the opposite would happen if you have a negative k. So quadrants 2, if you think of how you get there, it's a negative then positive. And so if k was a negative, and you divided by that positive, or that negative x, that's going to give you a positive. And then in quadrant 4, you get there by going positive then negative. So if you had that negative k and you divide that by your positive x, you're going to get a negative y, which makes you in that positive negative quadrant. So that's just always true. 1 and 3 are positive k, 2 and 4 are negative k. And that's it for inverse. So when I see you guys next time, we'll kind of talk about both direct and inverse and put them together. And then we will be doing a test on these two before winter break. So see you all soon.